Welcome to another edition of the Southwest Climate Podcast.
Is it the holiday edition?
It's the post-Thanksgiving, pre-Christmas, December edition.
Love it. Mistletoe everywhere in the podcast studios.
For those of you who don't know, that's Mike Crimmins. Mike, thanks for being here again, as always.
Thanks for being here, Zach. That's right.
All right, we have a lot to talk about.
We do.
So what we're going to do today is recap a little bit of what's happened in October and November. October, semi-boring if you ask me.
Hot.
Well, we'll get to
again,
that.
was this one of these months where you weren't here?
No, I was here for the most part.
Okay.
But the parts that I can't recall, I'll turn to you. Okay. Those are when I wasn't here.
All right. And I may have been here physically, but not mentally or emotionally. So
we'll do our customary thing, which is recap a little bit of the climate and weather in the last couple months, and then we've got some exciting events that are on the near term horizon. We've got the polar vortex rearing its head again. Remember the polar vortex?
I do remember the polar vortex, yeah.
Harken back to 2014, where this became embedded into the collective consciousness.
Love it. I use it in conversation every day.
You use the polar vortex?
Sure, yeah.
Stratospheric or tropospheric?
Oh, jeez. Wow. I haven't gone that deep in the vernacular.
Okay, so the polar vortex, we got an atmospheric river barreling down on coastal California.
You're going full tilt on your meteorological vocabulary here.
Yep, atmospheric river. We'll talk a little bit about that. And then there's been some other interesting news out. NOAA just released a report on the Arctic scorecard, which reports the last year of conditions in the Arctic.
Not scoring very well.
Yeah, not scoring. Well, it depends on if extreme is a good score or a bad score.
It's usually a bad score. Yes.
Okay, so we have a lot to talk about, a little time, and so hopefully y'all will stick with us here.
Hang in there, folks. It'll be a wild ride.
Okay, Mike, so why don't we first talk about the long-term weather conditions that have happened in the last couple months. So October, as we talked about in our last podcast, was epically hot, didn't bring a lot of precipitation.
Yeah, very warm, very little precip to much of the Southwest.
October actually just had a few days of precipitation, but then we rolled into November and things got a little bit more wild and woolly, if you will.
Yeah, I think we started to see a little bit more of a transition into what we'd expect to see in late fall, early winter. The weather systems got a bit more busy. The jet stream became a little bit more progressive, started sort of slinging some weather systems across the Southwest. Including a couple of unusual-ish events, maybe not so unusual for us, but you don't see them every day, like a cutoff low pressure system sort of wandering around Southwest, and another deep closed low dove right south of us and didn't bring us any precip. We actually thought it would, and carved through northern Mexico and then just kind of cruised off to the east. We
had sort of more of the wavy traditional transition jet stream that brought storms rolling in from the Pacific Northwest, more or less. Mm-hmm. But those didn't bring much in the way of precipitation to the area.
No, and at this time of year, you either are working with subtropical moisture to the south, and you've got to, you're kind of dragging in some of that little kind of, this again will be very late season subtropical moisture hanging on from the monsoon season. That stuff is really getting shunted much of it's further to the south, or the storm has actually got to bring its moisture with it from the Pacific Northwest or from the Gulf of Alaska. It's tough because the storms typically aren't diving that far south and bringing the moisture with them in a sort of a real efficient manner. So we had a couple of storms in November carve across the northern part of the state, had some decent cold temperatures, so put down a little bit of snow at higher elevations, but it didn't really do much for sort of southern Arizona, lower elevations, or southern New Mexico.
Here in Tucson, starting in November 1, I think we only had... we had a relatively decent amount of precip, close to a half an inch on, November 3rd?
November 3rd, yep.
And then it was pretty quiet up until November 27th and 28th.
Yeah.
And those days were just a sprinkling, more or less.
The month was not boring from a weather perspective. I mean, there was a lot going on. It wasn't like we were parked underneath a very strong ridge of high pressure like we saw in October. The jet stream was progressive. We would have small short-term ridging move in and warm us up for a couple of days, and then a low-pressure system would come out of the northwest and cool us down. Some of those systems had more moisture. Most of that was actually hitting kind of the northwest part of the state and some of the higher elevations. Mm-hmm. So Flagstaff picked up multiple precip events during that month. But as the further you got south, you just got left out of the action. So Tucson saw the weather systems kind of go by, but didn't really get much out of it as far as precip as the month went on.
If you just look at Tucson over the last 90 days or so, we're running close to 2 inches actually below what we normally get. But yeah, as you say, more of the precip fell into northwest regions. November isn't that wet to begin with, but
yeah, I mean, we're talking kind of low bar months here. So as you pop way above average as far as percent of average, use that metric. It doesn't take a lot. Overall, the Southwest as a whole it's not been a knockdown, drag out wet couple of months so far.
Any relation to the tropical Pacific Ocean here? I mean, we've been dry, if you look broader in the West, Southern California, Arizona, New Mexico, last month has seen drier conditions, which is what you would expect during a La Niña, which we have currently. We'll talk more about this in a minute. It's a weak La Niña, but can we make any sort of, dare I say, attribution?
No. I mean, you could. I mean, you could attribute all sorts of things to all sorts of things. I don't see much of a causal link. I mean, again, we got to go back to even the way we talked about El Nino last year. When we were in this transition season, October, November, if you kind of think back to those, we were looking for impacts. We weren't seeing them, but we know if we go back to the statistics and even the dynamics that the influence of La Nina or El Nino in the early fall season is pretty weak. Right. So we wouldn't expect a lot of, I think, impact even if we had a strong La Nina. I mean, I think we'd be more tempted if there was zero precip, strong ridging across the region, and it was a strong La Nina, maybe the attribution, we would probably lean in that direction. If you go back to November, there was some discussion that the Madden-Julian oscillation was actually fairly active and kind of made a run around the globe at that point. My guess is that was in play. And as we've talked about too, there's some of the cutting edge seasonal forecasters are looking to other things like Eurasian snow cover in October, sort of leading to changes in the Arctic oscillation, changes in sea ice extent, all sort of starting to come into play in the early fall.
Do those have an expression down here? Because my understanding is sort of the Arctic oscillation or the North Atlantic oscillation, it's more tied to what's going on in the northeast region of the U.S. and even further east of that.
In the fall, the expression is much more local and higher latitude, and then it can come into play as you get into January and February, even to lower latitudes, because you get into these. Remember, you think about the whole northern hemisphere in the wintertime, the poles are getting no sunlight, right? Yeah. And so they're cooling off very quickly, but they're also interacting with the sea ice decline, which is really the changing part of the system, which we don't really have our heads totally around, but it's clearly creating some uncertainty in the system and some instability. But the whole weather systems start to drop to lower latitudes. And so that's why, we get into our core season here as far as wintertime precip in January, February, March, when you get to the lowest latitude extent of some of the jet stream activity. Then Arctic oscillation can come into play because you've got cold air that's sort of wandering around off the poles that can end up getting introduced all the way down here. What was the big freezing event in 2012? February 2012? 2011 or 2012? I was getting mixed up. But we had that situation where that Arctic air was not on the poles, wasn't bottled up there. It was wandering down at lower latitudes. We just had the right jet stream pattern to basically give it a straight north to south pattern into the southwest.
You're preempting our conversation about the polar vortex, because this is related to, normally those cold, not normally, but oftentimes the winds that are sort of circle the polar region, which is called the polar vortex.
It is. Yes.
Exactly. When they're stronger, they're sort of tighter and they bottle up that air. And then when they weaken, the maximum strength in the winds, it sort of spills southward and you get more wavy sort of margin of the polar vortex. And I believe that's what happened then, right?
Yeah, I think that's right. And the strengthening and weakening of the polar vortex is a common weather feature within each season, but we can have it sort of lean towards being a weaker polar jet, more of this, production of cold air off of the poles and then spilling south, which is where you get into those winters in the East Coast like they had not last winter, but previous winters. And you can also have them in the opposite, where the jet stream polar jet is tight,
right,
and that cold air is sort of really bottled up, like you said.
The forecast for this upcoming weekend in the East Coast is, in some places, it's going to be 30 to 40 degrees below their average. So this is, I think they're calling for sort of record low temperatures in some places. But it's also worth saying that, whenever you have these sort of spills south of these Arctic air, you're going to have record cold temperatures in some places.
Yeah, absolutely. I mean, and you have to think about it in the totality of looking at the global pattern too, is that there's going to be what ends up happening in those situations when that cold air is far south. It's sort of often used as sort of evidence that clearly global warming isn't occurring. But if you look at the pattern of the whole globe, what you end up seeing is that at the poles, the temperature anomalies are enormously above average because the cold air isn't there. It's actually offset off of the poles.
Right. The polar vortex, like you said before, I think you said it, that this is a common actual feature.
It is a feature of the Earth's meteorology.
Yeah.
It's not a new emergent phenomenon in our climate system.
Although we've been talking about it in the last couple of years as if it is new. And interestingly, there's a couple actually polar vortex. There's a stratospheric vortex and there's a tropospheric vortex.
Yeah, I mean, and they're coupled and they can become uncoupled and they can split. And this is actually the frontier of seasonal forecasting. Is some seasonal forecasters actually looking into that to give them indication of what the next several months will look like.
Yeah, one of the ways that people measure this is through the Arctic Oscillation Index.
Yep.
And the North Atlantic Oscillation Index. And those two things measure sort of the pressure differences in certain places in the northern regions, and they're correlated with each other, so they're often used interchangeably. And when you have negative index values, you tend to have the ability for cold air to spill south more than when they're higher index values. And basically what a negative value is when you have higher pressure actually over the Arctic, and positive values are when you have lower pressure over the Arctic. So people are paying attention to the Arctic Oscillation and North Atlantic Oscillation during the winter months because they do have an influence on temperatures, most notably in the eastern U.S.
They can have implications across the globe and implications on the jet stream pattern, which ends up affecting us as we get deeper and deeper into the winter season. So it is indeed all connected. So we'll be paying attention to this over the next couple of months.
So I wanted to go back a little bit because we've had sort of dryish conditions in the last couple months, but we've also had very warm conditions. I believe if you look at Arizona as a whole, November and October came in as tied for the warmest on record. And we're coming off of, again, of a really warm year in which that the El Nino, although it didn't express itself in precipitation here in our area, but it certainly had an influence on global temperatures and regional temperatures. I believe the U.S. as a whole came in at one of the warmest on record, if not the warmest on record.
The October story was fairly simple. We had almost every day of the month, depending on the location you were at, had an above average daily max temperature and above average daily min temperature. It's a pretty much a slam dunk as you go in there. November, we got into some weather scale variability. We had a couple of days that were, I think, record or near record, depending on the city you were at here in the Southwest in November as far as temps. But then we also had a couple of very cold days. And some of the first freezing events of the season in some of the cities actually occurred there too. So again, that's that as you get into the winter season here, the jet's now approaching us from the north. It's becoming more active. It's dropping to lower latitudes. So you're going to end up having the warm-ups ahead of the storm systems and then the cool-downs as the low-pressure systems sort of skate by. And even as we're recording this podcast right now, we're actually into a run-up of days here. We're going to hit probably 80 degrees here in Tucson. Not unprecedented for December, but warm, clearly very warm. And on the backside of that will be this low pressure system that'll move through and then cool us off. So it's, it's kind of part of that transition.
Yeah. And when you average those temperatures over the last month, so just looking at November, most of Arizona and New Mexico was 2 to 6 degrees warmer than average, but there were pockets that were right around normal.
Yeah, you get into that sort of, average to 2 degree, but on totality, because of a couple of those warm up events, and then the overnight lows were quite a bit above average as well for most of those days, except for a couple where we dropped below average.
It's classic snowbird weather.
It's beautiful. It's a postcard, Chamber of Commerce. I mean, I've heard all of those terms coming out over the last couple of days.
I mean, this is glory time here in the Southwest.
It is not bad. It is not bad. That is for sure.
Anything more we need to say about the recent conditions? It's still early for snowpack.
Yeah, too early for snowpack. I think it was, if you even look back to last November, I'm still sort of, living out what happened last fall as we were looking into the run-up of the El Nino. I can't let it go. Every podcast I have to bring it up. But I think it was even actually a little bit more active this
people
November.
People got to start sending you Christmas cards.
They probably will. Yeah, probably some kind of, we already talked about this. So there's no kind of climate-themed Hallmark cards. Maybe there are. Maybe
there's a market there.
There's probably a market there. But that this November was actually a bit more active precip-wise than last November, interestingly enough.
So we are in this sort of ENSO neutral-ish weak La Niña phase, whereas last year we were in a much more stronger signal.
Yeah.
And so you kind of would expect that the jet stream would be a little bit more free to wander.
Yeah, I guess.
Sounds good.
Yes, sure. Sounds good.
I mean, fact check me here.
It's the shoulder season of the expected height of the teleconnection between either El Nino or La Nina, right? Quite honestly, the fall is not when you have the strongest signal. I think we wanted it to be more last fall with the El Nino connection. We didn't really see it. Once we got into January, February, March, we didn't see it. Then we knew that we were in trouble. So we're now, as you say, I think you're generously giving this La Nina event some credit. It's borderline. Several of the meteorological agencies internationally, including the Australians, they're not even giving it props, right? I don't think they're even going to call it La Nina. So it's been borderline. The expression in the atmosphere has been unimpressive.
It just actually picked up in the last month, right?
Yeah.
Like before it was...
Yeah, it started to like, was I supposed to do something sort of attitude? And then it's kind of waning again.
I believe this is actually the third overlapping season. So average 3 months.
Yeah.
These are the sea surface temperatures in a particular region in a box in the central eastern tropical Pacific Ocean that, during La Nina conditions are on average below 0.5. And so for a definition of a La Nina event, you have to have, for the ONI index, 5 overlapping 3-month seasons in which conditions are below 0.5 degrees Celsius.
Is it really?
Yeah.
5? Okay.
I think it's 5.
Sounds good to me. Yeah.
Now we've hit 3.
Uh-huh.
This is the third.
Are you sure it's 5?
I believe it is 5.
That's a lot.
The definition.
That's a high bar to clear. Could be.
For it to be defined as an El Nino in retrospect.
Okay.
Excuse me, La Nina in this case. For an ENSO event. Yeah, we'll have to do some online fact checking right here. I know. I see you typing away.
It seems
definition. Look up Siri. Definition of.
I should yell at my phone. Why aren't you yelling at your phone to do it? Yeah, you're right. Historical purposes, periods of below and above normal SST. This is Siri talking right now. Are colored in blue and red when the threshold is met for a minimum of 5 consecutive overlapping seasons.
Boom. Zach 1,
High
Mike
bar.
0. I'm only keeping score when I actually tally points.
That's great. That's great. I guess I should be doing the same for myself.
This is a weak La Nina.
Yeah,
event.
it's
but
right.
In a way, whether or not it's La Nina by a slim margin or neutral by a slim margin is probably immaterial.
The reason we care about this at all is that it has got a link to some kind of impacts, right?
Right.
And
notably precipitation.
Notably here.
Notably
right?
here,
I mean, there's been, I think, expressions of local impacts with the weak La Nina conditions more proximal to where it was occurring in the Pacific Ocean and across the Pacific Basin. But I don't think they've been terribly strong, and they've been a little bit disconnected from the atmosphere. And now we're crossing into the season where it matters most to us here in the Southwest, sort of really next month, January, February, March. And the forecasts, quite honestly, are that it probably won't hang together. That kind of leaves us at this crux of, well, so what? What does it mean?
So what?
I don't know. I mean, so the forecasts, the seasonal forecasts, clearly are leaning heavily on this sort of lingering La Nina pattern. They put us at below average, higher probability of seeing below average.
The CPC's forecasts have this swath of slightly tilted odds for below average conditions across the southern tier of the U.S.
It looks like a classic La Nina forecast.
Classic La Nina. And of course, the tilted odds for above average precipitation in the Pacific Northwest area and then parts of the Great Lakes area.
We're now in a situation where the La Nina event it's not really there, and it's not really expected to strengthen, probably be gone by the core of the season. It doesn't really suggest that there'll be a strong atmospheric signal that would push the Southwest towards dry, but maybe there are other factors at play, because the dynamical models are sort of leaning in that direction too. But quite honestly, if you look across the dynamical models, they're not very consistent. You get this totally washed out signal, which to me is highly uncertain forecasts going forward.
Of course, the forecast that the CPC is issuing is not for average conditions.
It's not. And it's not a single deterministic output. They're not just taking these model output and then drawing the map on there. They're trying to do this sort of balance of information, and other tools sort of suggesting that there'll be this dry signal. And given the sort of pessimism you have about winter precip in the Southwest after you live here for a while, it's probably a good strategy to just sort of expect below average and then be surprised or happy when it doesn't turn out that way.
Traditionally, we've thought about these forecast tools as being functional and useful for the public. Maybe a good way to think about seasonal forecasting is just think about what has happened, the full range of variability in our past.
Yeah.
And think about whether or not the decisions that people make based on the climate is sort of robust to that full range.
Yeah, I think it's trying to think of using these in win-win situations. We're not confident enough in them and their historical performance to say that you do some kind of high-risk venture with it. I don't think anybody does that. Right. And I think that, it was such a good road test of this thinking last fall when we got into a strong El Nino and we expected to have this particular response. It was a forecast of opportunity because the science had led us up to that point.
Right.
And it didn't really turn out that way. And we're still sort of sorting out what actually happened from that. It was very humbling for me. Again, this is not to say that the whole venture is not useful, but it was sort of a wake-up call on, what information do we have? What information don't we have, and what do we need to sort of work on going forward?
Yeah, it's also an opportunity to think about how we talk and understand and communicate about uncertainty, because nobody would have said, even given last year's conditions, like one of the three strongest El Niños, and we do know, at least in some places like California and southern Arizona, that strength does influence the precipitation pattern. Mm-hmm. Even in those conditions, there's always chances for it to go counter. People often say, the forecast can never be wrong because it's a probabilistic forecast. Of course, people can make wrong decisions based on
that's
the
just it. I mean, you have binary decisions based on a range of possible outcomes. And however you sort of carve up last winter, especially when you expected the teleconnection to be strongest in January, February, March, we ended up having that very outside probability of there was that dry tail in there, and that ended up happening. Yeah, it's a real challenge when you've got uncertain information you have to make a binary decision with.
Right. It's almost like each year has its own flavor, and we don't have a long record for these El Nino events or La Nina events or neutral events, and we haven't really captured the full range.
No.
It is, on the one hand, hard to come up with analogs like 97, 98, or 82, 83. They all sort of have their own unique expressions, in part because, we have 22, 23 El Nino events, a very few number of strong events. And so bringing all of the information together seems like an important way to go. And that's probably what we need to do this year, given the fact that we're in a La Nina, but it's a weak La Nina. So
this is an ongoing scientific adventure that we're on, is understanding the climate system in real time at the same time that it's changing underneath our feet, right? It'd be one thing if the system was not being sort of externally forced by climate change, but we would then just be trying to uncovering the gears and the parts and the nuances of the fine thing. But the system, the way that we thought the dynamics worked 20 years ago may be different than the way it's working this upcoming year. So it's
a lot has changed in 20 years.
Right. I mean, and so and clearly El Nino is part of, and La Nina are part of the changes that are ongoing in the system. So your mechanistic thinking of it at one point in time may not hold true as it moves forward. So that makes it even more challenging. And as we were talking about, there are things like now that we're leaning on or experimenting with as far as seasonal forecasting, the influence of the change in sea ice on the wintertime jet stream variability as you get into later in the season, right? Yeah. And so there's really interesting papers that have come out in the last year or two that talk about the pattern of where the sea ice decline is occurring and where the ice sort of builds back up into the fall season, that it has nuances on the remaining how the rest of the winter plays out. Whereas if you get snow accumulation in Eurasia or not, and then that ends up feeding back to the disruption of the sudden stratospheric warming events and the split of the polar vortex and then the change in the atmospheric.
Yeah, it's all connected. There's so many strings tied together.
Yeah, and they're all
you tug one, and they're all
rough conceptualizations right now, right? There's some interesting blogs now in seasonal forecasts for this year saying this is going to be an interesting test of this hypothesis this year. We're learning in real time in a system that's changing. So it's a crazy crazy adventure.
So I'm glad you brought up the Arctic and the sea ice, because I think NOAA released their Arctic report card. So the average surface temperature of the year ending in September, so the October through September 2016 period, was the highest since 1990, so warmest conditions. That sort of mirrors what we've experienced globally. The record El Nino had something to do with that. The changes in the polar regions, however, are more dramatic than changes elsewhere due to this sort of feedback mechanism called the polar amplification. Mm-hmm. Another highlight is after only modest changes from 2013 to 2015, the minimum sea ice extent at the end of the summer of 2016 was tied for the second lowest in the satellite record. And that satellite record began in 1979. So there's major changes going up in the Arctic. Another highlight is in 37 years of the Greenland ice sheet observations, only 1 year has had an earlier onset of spring melting than it did in 2016. I think those are the major highlights. But you can download that report if you just search Arctic report card on Google.
It has implications even for the Southwest. And I think that that's the stuff that we're now sorting out, that it indeed is all connected. There's been some really interesting research on the connection between the Arctic Oscillation and the Madden-Julian Oscillation. You get these sort of lagging and leading dances between oscillations that will then influence weather systems across the Southwest. Not having a strong La Niña signal, sort of kind of bringing it full circle back to the seasonal forecast, is that we are in a territory right now where we're basically in neutral. So neutral then means you have not much to work with as far as a seasonal forecast. The CPC forecast, I think, has got this sort of lingering La Niña pattern. Maybe that'll be something that does influence our weather system. I'm sort of leaning now to having a much more lower confidence. I'm feeling much more uncertain about this. Then the Madden-Julian oscillation, if it is active, you get these sort of waves of ridges and troughs and the kinds of atmospheric river events that potentially come into play. Whereas if you get 2 or 3 of these heavy rain events broken up in the season, the whole Southwest could go wet, but have 2 or 3 rain events, and you get this completely opposite forecast. Then you have to think about, well, does that actually solve any drought conditions? Is it the same as getting snowpack built up across the region? It's even like, how do we characterize drought down here? A couple of rainy events broken up by 90 days of hot, dry conditions doesn't mean the same as having a nice built-up snowpack and some even nicely...
Yeah, the character matters.
Yeah, character of the precip matters.
A lot of our predictability comes from when we have strong signals from the tropics. Mm-hmm. And when those signals sort of shrink, the strength of those signals shrink a little bit, become less influential, we turn our attention to some of the places that could impact our weather, and they begin to exert some
subseasonal variability.
Yeah, subseasonal
down to
variability.
Weather scale variability.
So
right.
I think in my mind, that's why strength matters for in terms of our precipitation pattern and its relation to ENSO events, is because when you have a really strong event, the tropical Pacific can override some of these other competing influences.
That's right. It's supposed to muscle its way and sort of shift the weather scale variability towards some part of the distribution away from others, depending on these larger signals.
A lot of our thinking in climatology has been focused on the tropics. Do you think now that people are beginning to realize, or maybe they realized it for a while now, that it's not just the tropics that are controlling it, that it's also, what goes on at higher latitudes?
I think the conventional wisdom still is that the tropics drive the global climate system, even in the wintertime systems of either hemisphere. But I think that we're getting a much more nuanced understanding, or at least that we've got to look at the directions and the connections between the two. Because we're now seeing that things that happen in the tropics that then translate up to higher latitudes over seasons and years, and then you can actually have the same type of situation influence subtropical and tropical variability in the other direction. So there's a lot of moving parts. Really nice post on the ENSO, climate.gov ENSO blog on the Pacific meridional mode, which has been talked about for over a decade. We really saw it sort of rear its head and become an important player over the last 2 years as something that was a bit different, and its behavior was a bit different with the latest El Nino, which may be part of why it didn't behave as the way we expected it to, and also its behavior post El Nino, not crashing into a La Nina like 97, 98, and also why this La Nina event may not have been able to hang in there is like this yet another flavor of the sort of tropical to mid-latitude connection. As you get this sort of large conceptual model and it kind of works for most things, and then it doesn't work, and then you go to the next level, and then,
that's how we refine our understanding.
That's how science works, right? And again, the system is changing underneath their feet. So we've got this complexity of a very complex system we don't have totally dialed in, and it's changing. So it gives you this whole other added bit of variability that you've got to account for.
So you brought up something that we should talk about, which is what's on the immediate horizon, these atmospheric rivers. And an atmospheric river, more or less, is this large area in the atmosphere that streams moisture from more of the tropical regions up to higher latitudes. And one of them is currently, I believe, dousing California as we speak.
This is sort of the transition season. People will note that, and especially in the Pacific Northwest, is that November is actually a very wet month for the Pacific Northwest, as the jet stream is now starting to move south with the cold air to the north and the whole cooling off of the hemisphere. So you get, I think that's part of this sort of transition. But these atmospheric rivers, if they can pick up that subtropical moisture, can be fire hoses.
But on average, they transport about 30 to 50% of the annual precipitation for the West Coast. So these are events that dominate the seasonal precipitation signal.
Big time. And you can get down to Southern California, and even if they can wander their way into the Southwest, they can be as equivalent. We don't get them every year, but when we do get them, they can be, they can make up 3/4 of the seasonal precip.
Yeah, it's not just a West Coast expression. These atmospheric rivers actually occur globally.
Yep. Some good research on them coming into Europe and in the Southern Hemisphere as well.
Yeah, so I said sort of a thin band of moisture transport, but they're actually, on average, 400 to 600 kilometers wide. So
yeah, but I mean it's still relatively speaking.
Right.
If you look at them on a satellite loop, they're these filaments of moisture that are connected right down to the tropics that get extended up into the mid-latitudes.
Now they can, because they're transporting tropical moisture, and so the soupy, slightly warmer atmosphere lowers the snowpack elevation.
Yeah, they typically, they have a warm channel with them. So they end up being more rain producers and higher snow level type events, unless they can have a really good, strong interaction with cold air to the north. There's some research to suggest that they're related to the Madden-Julian oscillation too. So you can actually get these atmospheric rivers originate with certain modes of the MJO coming across the Pacific Ocean. The MJO actually requires to have some component of easterly winds, trade winds, at the equator. So if you have El Nino crash them, then typically what ends up happening is that the MJO can't propagate into the trades because the trades aren't strong enough to have it propagate. So I think that's some of the thinking, is that during neutral and La Niñas with those stronger trades, the MJO is more active, can be more active anyways. And, again, this is what looking forward to the rest of the winter is that anything's possible, and the MJO may become more of a player, may set the Southwest up for one or two of these types of events.
And these events, these ARs can actually stream into Arizona.
They can, yeah.
They oftentimes clip our northwest corner more than they do.
They do.
And that's just because they're sort of directed in, and they have to sort of pass through some topography to our west.
They have to literally thread a needle of topography, and their approach and their angle of approach from lower latitudes has got to cross 2 or 3 passes along the coastal range of Baja and Southern California to actually make it into Southern Arizona. So that's why they don't happen, every year or multiple times a year, is that they have to be a pretty unique set of conditions.
Okay, I think we covered some wide territory there, from atmospheric rivers,
we did it.
The polar vortex to the Arctic to the tropics.
We did the full latitudinal.
Should we talk about India?
Do you want to? We can go other side of the world.
Austria.
Just should.
No, I don't have much to say about it.
I don't have anything to say either. Yeah, I'm good.
All right, so that was our holiday edition. We'll come back after the new year and
we'll check on the status of La Niña. I guess we'll see where we're at with a lot of stuff.
All right, Mike, thanks as always
Thanks, Zach,
for the color commentary.
Yep, and thanks, Ben, for making this listenable.
The Southwest Climate Podcast is a production of CLIMAS, which is part of NOAA's Regional Integrated Science and Assessment Program and is housed at the University of Arizona Institute of the Environment. Mike Crimmins is a principal investigator with CLIMAS, a professor of soil, water, and environmental science in the College of Agriculture and Life Sciences, and climate extension specialist with the University of Arizona Cooperative Extension. Zack Guido is a research scientist with the Institute of the Environment and UA program manager of the International Research and Applications Program. The podcast is edited and produced by Ben McMahon, research, outreach, and assessment specialist with CLIMAS.
Is that a word? listenable.
Yeah.
I think so.
Okay.
It's better than sudden stratospheric warming.
It probably is.